Assalamu alaikum wa rahmatullahi wa barakatuh. How are you, my dear students? Today, inshallah, we're going to start on the last part on grade 11 syllabus, which is functions. We'll start first of all with the meaning of the word function. So as you see, when y is in terms of x, so we call that function. Function is y as the subject and x is the variable, y is subject and x is the variable, and the expression is given to you y in terms of x. For example, this is a function y equals 2x plus 1. So as you see, y is the subject and x is the variable. We have four types of functions. First type, we called it one-to-one relationship. One-to-one relationship. What that means? Each value of x has only one value of y. So 1x is only representing one value of y. So like the straight line equations. So we call that one-to-one relationship, and we call that y is a function of x. Why? Because y is the subject and x is the variable, so we have to say that y is a function of x. Second type, we called it many to one. So what that means? Many x values representing only one value of x, one value of y. So we call that many to one relationship. Many x values, many values of x have only one value of y. And we call that many to one relationship. So we call that y is a function of x. For example, y is equal to x squared, which is the parabola, the quadratic curve. 1, if you replace x as 1, so 1 power of 2 will give you 1. So which means this point has the coordinates of 1 and 1. And if you replace negative 1, so negative 1 squared will give you positive 1. So this point has the coordinates of negative 1 to 1. So negative 1 and 1 are two different values. So these two values representing many values of x, and both of them give you the same value of y. So we called it many to one relationship. The other two types, because I told you we have four types, the third type, one to many relationship. So this is the opposite of many to one. So what you have to say here, one value of x has many values of y. So we call that one to many relationship, and we couldn't say that y is not, we couldn't say y is a function of x. Y is not function of x, but the real idea is to say that x is a function of y, because x is the subject and y is the variable. Why? See, this is the same value of the x. If we replace x as 1, 1 is equal to 1 y squared. So if you want to find the values of y, you're supposed to take the square root of both sides. Then you'll get 1 and negative 1. So this point has the coordinates of 1 and 1, and this point has the coordinates of 1 and negative 1. See, you have the same x value, but two different values of y. So we couldn't say that here y is a function of x, but we're supposed to say that x is a function of y, which means we couldn't say that this type is a function, because the function y is supposed to be in terms of x. Fourth type, many to many relationship. The famous example of these types of functions, because we call them functions, but we couldn't say that y is a function of x, is the circle equation. X squared plus y squared is equal to 9, because we don't have x in terms of y or y in terms of x. We couldn't say that one of them is a subject of the other. So many values of x will give many values of y. So y is not a function of x, and x is not function of y. We start in another point, which we're going to talk about x values and y values. Simply, we call the x values as domain and y values as the range. All x values that we can use them on any function, so we call it domain, or we can call it input. So whenever you want to find the y values, you just replace x value to find the y. So x is like input, like you have a machine, and you just put some values to get the corresponding values of y. So range, all the y values that we get them from using any x values. So we call that output. We start on exercise 2a from the textbook, page 18 from C3, C4 textbook, and you have the PDF copy. Question number 1, find the range of these functions and state whether each function is 1-to-1 or many-to-1. For example, f since x is equal to 2x, so is the same as f of x is equal to 2x. Domain which is given to you in the question are the values 0, 2, 4, 8, which means we're supposed to use the x values for this domain. So once you replace x as 0, 2 by 0 will give you 0. Replacing x as 2, so 2 times 2 is 4. Replace x as 4, so 2 times 4 is 8. And then replace x as 8, so we'll get y as 16. Now, these values, we call them range. So whenever using any x value, all the corresponding values of y, we call them the range. So domain x values, range y values. Let's do this question. F of x is equal to x squared plus 1, and the domain is x belongs to R. Now, we're supposed to state the range. So simply, you can use, instead of using values, we can use the sketch as well. Let's use different values of x. I'll start from the 0. X equals to 0. So you'll get y equals to 0 squared plus 1, which is equal to 1. Using x equals to 1, y equals to 1 squared plus 1, which is equal to 2. Let's use x equals to negative 1, y equals to negative 1 squared plus 1, so equals to 2 as well. So we have to state, remember that, we have to say that, what do you call this type, what do you call this function? Is it one to many, 1-to-1, or many-to-1? So based on that, using two different values of x, and you got two same values of y, two different values of x will give you two same values of y. So we call that, this function, many-to-1 function. And in the previous question, it was 1-to-1, because each x value gave only one specific value of y. Now, let's use the sketch. As you see, the least value, using the 0, you get 1. See, this is the negative value. If you decide to use the negative value as well, so negative will change it to positive, because negative to the power of any even power is equal to positive. So this is the least value that you're going to reach. Based on the sketch, x squared plus 1 is a parabola which is translated upwards 1 unit. So the vertex, or the minimum value, is 1. You couldn't find any value less than 1 for the y. This is the y axis, and this is the x axis. Now, if the domain is x belongs to R, so we can write that range y belongs to R, and R, by the way, we call them real numbers. What do you mean by the real numbers? All types of numbers, whatever roots, radicals, positive, negative, 0, decimals, fraction, all the types of numbers. So y belongs to R. So range y belongs to R, but we couldn't say that the whole y-axis, because you see, all the values less than 1 are not related to the function. So what you're supposed to write here, we're supposed to write that y greater than or equal to 1, which means all the values of y more than 1, including 1 itself. This is the range. Let's see the next question. F of x is equal to 2x cubed. Domain, x belongs to R, and the values from -1 to 4. So let's use the least value and the highest value. This is the least and this is the highest. Let's use x equals to -1 first. So y equals to 2 by -1 cubed, which is equal to -2. So this is the least value. And the highest value using 4. Y equals to 2 by 4 cubed, which is equal to 64 times 2, which is equal to 128. This is the least value and this is the highest value. So you're supposed to write that range y belongs to R and y between -2 and 128 based on this range. So the range is from -1 to 4. I know this is the domain, but I mean between only these two values, -1 to 4. So the least value, corresponding values of y from -2 to 128. This is the range. Now we have to state, is it many to 1 or 1 to 1? Basically in the cubic function, you couldn't say that many to 1. Whenever you're using positive, you'll find positive, negative will give you negative, not like the quadratic, not like the parabola. Parabola, positive and negative will give you the same value. So we have to say that here, many to 1, and here the type of the function is 1 to 1 function. Now this question is the opposite of the previous question. Find the largest possible domain of these functions and state whether each function is 1 to 1 or many to 1. Now they will give you the range and it's required to find the x values. So we have to do the opposite process. I'll start first of all using y when the y equals to 5. So 5 equals 2x minus 1. Move -1 to the other side. So 2x equals to 6. Then x is equal to 3. Y equals to 10. So 10 equals 2x minus 1. Move -1 to the other side. Then 2x is equal to 11. So x is equal to 11 over 2. Using y equals to 15. So 15 equals to x minus 1. Move -1 to the other side. So 2x is equal to 16, which means x is equal to 8. Just by dividing both sides by the coefficient of the x. And when y is equal to 20, so 20 equals 2x minus 1. Move -1 to the other side. And 2x is equal to 21, which means x is equal to 21 over 2. These values representing the domain, because this is the range which is given to you. So we can write here, domain are the values 3, 11 over 2, 8, and 21 over 2. Now we have to state the type of this function. All the straight line equations, we call them 1 to 1. Except the straight line, the vertical lines and the horizontal lines. We called it many to 1. Because all the x values will give you the same y values, or all the y values will give you the same x values, based on the vertical or horizontal. So but for the straight lines in the form of y equals mx plus c or y equals mx, we called it 1 to 1 function, because each x value give you only one value of y. Root of x. The square root is representing like this. Y equals root of x. And we represented before. So root of x, each x value will give you only one y value. Let's see that. So this is the range, least value 2, highest value 7. So when y equals to 2, so 2 equals root of x, by squaring both sides, so you'll find x is equal to 4. Then when y equals to 7, so 7 squared equals root of x all squared, so y or x is equal to 49. So this is the least x value and this is the highest x value. So we call that the domain. So domain x belongs to R, which means real numbers. So x enclosed between 4 and 49. This is the domain. What is the type of this function? Is it one-to-one or many-to-one? For the root, we have to say that many-to-one. But into this case, if you have the other part, so we have to say that many-to-one. Many x values will give you only one x will give you only two values of y. 1x will give you 1y or give you 2y. This is in case of you have the whole graph of root of x. But into this case you have only one part, so we have to say that one-to-one function. One-to-one function. By the way, replacing x value as 4, we can find two y values, positive 2 and negative 2. But into this case, you have only this range, which is 2 to 7. So we have to say that it's one-to-one if you have only this part. But for the whole graph, we will have one or many-to-one. Many-to-one. This is a reciprocal 1 over x minus 6. If you just back to chapter 7 that we did in transformations, this curve is translated 6 units to the right. I'll just remind you about the graph. This is 1 over x, y equals to 1 over x. So if you move this curve to the right, you'll have this curve will cross the y-axis and this curve will be away from the x and the y-axis. Now this is the domain, this is the range. Now we have to see the domain. So I'll use y value as 1 over 6 first. So 1 over 6 equals 1 over x minus 6. Then do cross multiplying. X minus 6 is equal to 6. Then x is equal to 12. Then use y value as 1. So 1 equals 1 over x minus 6. Then do cross multiplying. X minus 6 is equal to 1. Then x is equal to 7. So say that, you have to say that domain x belongs to R and x between 7 to 12. This is the range, and we have to say that it's 1 to 1. Now, another type of functions, which we call it composite functions. What do you mean by the composite functions? When you have to combine two functions, combining two functions to be only one function. So we call that composite functions. In exercise 2b, into page 223 from the textbook, f of x is equal to 3x plus 4. And g of x is equal to x squared. Find g of 2. This is simply, you have to replace the x as 2. So you do 3 times 2 plus 4, which is equal to 6 plus 4 equals to 10. And that's it. Now, f of g of 2, which means you have to replace the value of g of 2 in f of x. So this is f of x, and this is the value of g2. So f of 10, which means you have to replace 10 on this function. 3 by 10 plus 4 equals to 34. Now, f of gx, which means you have to use g into f without replacing any values. What you're supposed to do, you just replace the x variable as the x squared, because you're going to use this into this. So f g of x equals to 3 instead of the x right, x squared plus 4. Now it's required to find f g of 2, which means you have to replace x into this function as 2. So f g of 2, which means 3 by 2 squared plus 4. 3 times 4 is equal to 12, and 12 plus 4 is 16.